In this video, we are going to learn how you start solving exponential equations, how you solve for x in problems where x is actually in the exponents. And as this lesson progresses here, we're going to need to introduce a brand new concept called a logarithm. And a logarithm is one of the more confusing, kind of intimidating concepts that we learn about in Algebra 2. So it's going to be really important that we take them one little piece at a time and make sure they're making sense because they can be pretty challenging for kids if you're not practicing. So let's start out with a little do now right here, where we're looking at two basic exponential equations. At least try your best to solve this first equation for x, and for the second one here, you can try to use a calculator to help you out. Okay? So, going over our two problems here. On this first example, we really don't know how to get x by itself in a problem like this. Kids will be like, oh, divide by 2, but even if you somehow could divide by 2, your x is kind of stuck in the exponent here, and dividing by 2 wouldn't fix that. If you did that, you'd get 16 for your answer, but 2 to the 16th power most definitely does not equal 32. Our best option right now for solving an exponential is just guessing and checking, trying different exponents right here and figuring out which one, when you guess and check, gets you an answer of 32. The answer to this problem is going to be 5. And I only know that because I know that 2 to the 5th is 32. So you sort of just have to guess and check to get your answer. Now, guess and check works out great when the answer is actually clean, but then you get to a problem like this one right here. There's not going to be a nice perfect exponent that works and gets you out a 20. So what I would have to do, well, 2 to the 4th power is 16. 2 to the 5th power is 32, so it's got to be somewhere between a 4 and a 5, and then you can just try different decimals. Well, what if I do 2 to the 4.2? That's only 18.3. What about 2 to the 4.3 power? Well, that's 19.6, so it's got to be 4.3 something probably. Maybe it's 2 to the 4.37. And then you just kind of play around with it like that, and you can get pretty close to what the actual answer is. Clearly, though, that's just a lot of guesswork, and we need a better way to get an exact answer. So here, I would basically, just in terms of what I'm going to write down, I know it's got to be between 4 and 5. And we found out that it was actually closer to like a 4.3-ish just by guessing and checking. But we need a better strategy for solving exponentials. In order to do that, we are going to need to introduce a new concept called a logarithm. So this problem right here, 2 to the x power equals 32. We're basically looking for the exponents that takes me, starting with 2, to an answer of 32. And the way we would write this out is as follows. So I'm going to give you like the rule and everything in just a second. You can just look at this for right now. First of all, I would pronounce this log base 2 of 32. Log base 2 of 32. And a log is just an exponent. It's the exponent that gets you from this number to this number right here. And we already saw by guessing and checking that the exponent that makes this problem work is a 5. So this log thing right here is really equal to 5. That's probably extremely confusing right now. Our job in this video is just learn what a log is and how to use it. So we're going to wrap our heads around that in today's lesson. So the first thing I'm going to do with this problem right here is I'm going to give you a rule for converting back and forth between exponential form and logarithmic form. Anytime you write a log, I like to use a cursive L so it doesn't look like a 1 right here. Logs have a base on them. I'm going to use just the letter A for this problem right here. Logs also have a number that you're taking the log of, like an inside. So I'm going to put a B for that. And logs also have an answer. So every log is going to have a base, an inside, and an answer. And you would pronounce this, just like I wrote for the last one, log base A of B equals C. So I've got this going on right here. This problem, this logarithmic notation, is equivalent to the following exponential equation. It's going to be A to the power of C equals B. Now, this all is probably pretty confusing right now, but I promise you this will end up being actually something very easy once you learn how to convert back and forth between these two forms. Now, I don't want to undersell this next thing I'm about to teach you, but it could be literally the greatest thing you have ever learned. It is that amazing. It is a rule or a trick that will allow you to go from a logarithmic form right here to exponential form over here. And it's going to be pretty amazing. In order to do this, I wish I had like a video of me so I can show you guys with my finger what's going on right here. But you are going to take your right index finger and you are going to place it right here on the base. So I need to see your finger right here on this base of A. The way that the converting rule works is it goes base to the answer power equals this inside number right here. Or again, you guys are using your finger right now. You're going to put here to here equals here, and there's a sweet sound effect that you're supposed to do when you convert these. It goes choo, 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 just like that. Okay? If you go A to the C power equals B, you get exactly what the exponential form says right here. So converting something out of this weird, crazy log form and into exponential form is just a matter of doing the little finger trick like that, and you can convert them. Again, logs are a lot to wrap your head around. They take a little practice, but if you use my little trick right there, it's really, really simple. So when I look at these problems right here, they're in this weird, crazy log format. I want to turn them into an equivalent exponential equation, which will be a lot easier for me to handle. So you take your finger, you put it on the base right here. It goes this number to this power equals this. Just like that. So it's going to say 5 to the power of 2 equals 25. And if you look, this dark blue and this light blue are two different ways of saying the same thing. They are equivalent to each other. But we obviously like the light blue better right now because we don't understand that much about logs. This is a true statement here in light blue. It's just a different way of writing the same thing. A log in general is just an exponent. So this guy right here, if I was going to look at it, this is the exponent that takes me from 5 to 25. And the exponent that takes me from 5 to 25 is totally 2. So whenever you get lost, and you will with log stuff, just remind yourself, a log is just an exponent. It's the exponent that makes your problem work. And in this video, we're just practicing the very basics. We're not learning crazy things like properties and stuff yet. We're just practicing and getting used to this weird new thing. So go ahead and try this next problem yourself. Pause me real fast and do that thing and convert it to exponential form. What you should have written is the base to the answer equals the inside, like this. And if you look at this, this is a true statement. If you do 2 to the negative third, you totally do get 1/8. It worked out great. Okay? So there's not much work to do, not anything to show, no calculations to do. It's just a matter of using this little trick. On this next problem, they've got letters, so we're not going to be able to make sure it makes logical sense like these first two right here. They also put the answer on the wrong side. It's fine if you want to leave it here, but if it makes you feel better, you can also move it to the right side where we're used to having it. This next one is going to say u to the v plus 3 power equals this inside. It will go u to the v plus 3 equals t minus 6. That's how you convert from log form into exponential form. Now what we're going to do is practice going in the other direction. So I'm going to give you the exponential form right here, and you're going to convert it back into log form. So I'm going to show you guys how to remember this here. It takes a little more thought going in the other direction, but it's so easy to check your work. First of all, I'm going to write down log. The number under the exponent, this 6 right here, goes under your log. So under the exponent is under the log. Answer goes on the inside. And we talked about how a log is just an exponent. So this log thing is equal to the exponent of the problem. That's kind of how I think these through. But if you're not sure and you're like, oh gosh, did I do that right? It takes literally 2 seconds to check your answer. Just do the sweet thing right here. You're going to have 6 to the power of 3 equals 216, which is totally what the original problem said. So these are equivalents. Okay? Pause the video and try these next two for yourself, and I'll write them down right here. On this next problem, it's going to say log base 3 to the 1 over 81 power, to the 1 over 81 on the inside equals -4. And if you check it, 3 to the -4 equals this, do the thing, you get the same results. My last problem is going to go log base t to the v minus 9, and I got to put the v minus 9 in parentheses to show this is all on the inside of the log. If I left it like this is bad because it's ambiguous. Is the 9 inside the log, or is it actually just this? So be clear when there's more than one term what's supposed to be on the inside. Equals u plus 4, and if you check it, it does work out. So that's our first big skill of this chapter, just being able to go back and forth between exponential and logarithmic form. The next thing we're going to do is look at what's called the common logarithm. So when I talk about a common log, I'm talking about what the default base is on a log if you don't see a base there. And if you actually knew this before, if you look on these calculators, there is a log button. It's right here next to the number 7. And when you hit that button, it does not let you put a base in place. What I'm going to do is type log of 100 in my calculator and just see what it does. The calculator tells me the answer for this is 2. Okay, so log of 100 is equal to 2. So your job right now, what is the base on this? What's going on right here? So that when I do this number to the second power, I get 100. Because if you do the thing, we're going to have, I don't know, to the second equals 100. And it turns out the default base for a log is actually base 10. So this is important. If you do not see a base on your log, the default base for logs is base 10. I'll talk about why they chose base 10 actually at the beginning of the next video. For right now, just learn the rule and you can see that it actually works. All right, so the common log is log base 10. We have 2 more kind of skills to talk about in this lesson. The next thing is being able to evaluate a log. When they use the word evaluate in math, they want an answer. They want to know what this thing is actually equal to. So the way you work these out, right now, I have no idea what this thing is. So what I'm going to do is I'm going to put equals x, because I truly don't know what this is equal to. Then what you're going to do is set up your little thing. Do the thing right here. to get rid of this weird, confusing log format. If you do that, you're going to have 2 to the x power equals 1/28. And to solve an equation like this, we're going to have to resort to guessing and checking. Right now, that's all we've got. If you play around with different exponents, you're going to find out that the answer to this is 7. So my original problem was saying, what's the exponent that gets me from 2 to 1/28? That exponent is a 7. So this thing is just 7 in disguise. Okay? Try out this next one for yourself right here. And on this next one, so you're pausing me and trying it, I have a base of 10. Since they don't give me one, I'm going to put equals x here, and I'm going to do the thing. I'm going to get 10 to the x power. And I could leave this as a 0.1, but I'm actually going to write it as 1/10. Same thing, but easier to understand. What's going to make this problem actually work out? Well, it's going to be an exponent of -1. If you do 10 to the negative first power, it moves it to the bottom and you get 1/10. So the answer to this second guy here is a -1. If you're ever trying to get a decimal or a fraction, you're probably looking at a negative exponent. And we have one more of this style to try out. If you set this one up, what you're going to have is 64 to the x power equals a 4. Now, this problem is a little bit weird compared to the other two, because if you think about it, x can't be a whole number. If I do a second power or a third power or something like that to a 64, my answer is going to get pretty big. So that can't be right. It also can't be a negative exponent, because if I did -1, for example, I'm going to end up getting 1/64. I'm going to get a decimal, not a smaller number. What does that leave me? What could my exponent be if it can't be a whole number and it can't be a negative number? So the answer is that it should end up being some sort of fraction or decimal for your exponents. And in order to figure out what that exponent is, it's actually easier to do these problems in reverse. Figure out 4 to what power makes a 64. Turns out 4 to the third is 64. That means the cube roots of 64, or the 1/3 power, equals 4. And you can type that in your calculator to check it, and it does end up working out. So when you're trying to get to a smaller number, it's easier, honestly, to do the problem backwards and then just do 1 over whatever makes that work. So those will take a little practice, but they're basically just knowing your powers. That little list I made you guys memorize a couple chapters ago, chapter 4, is coming back in these problems with logarithms. So our final skill of the lesson is actually a really easy shortcut once we develop it. What I want to do with this first example right here is actually go ahead and write down equals x and convert this thing. If I do my thing right here, I'm going to have 5 to the x power equals the inside, which is 5 to the third. Now, if you use a little bit of common sense on this, obviously x has to be 3. That thing that makes these say the same thing is if x is a third power right here. So basically, what I did when I look at this log is I was basically asking 5 to what power, because that's what it is, log is an exponent, 5 to what power makes 5 to the third? Well, 5 to what power makes 5 to the third? Clearly the answer to that is just 3. So a property of logs, if you have a base and a matching number with an exponent on the inside, you can think about it like this actually just cancels itself out. And all that's left is this number right here. So when I look at this next problem, you could go ahead and go through the whole process. Oh, I'm going to have this equals u to the 9th. Oh, the answer is x equals 9. Or you could just be like, hey, that cancels. U and U matched, it's gone. I just get 9 for my answer. Really easy to use, a little bit harder to wrap your head around, but not so bad to set up. Okay? Final thing, this also works in the other direction. So I'm actually going to start on this next example by doing my exponents and figuring out an answer for just that guy. So if I look at just my exponent here, I'm going to have 7 to the x equals 49. If I do the thing, I'm going to find that my answer for the exponent, this green exponent, is really a 2. So now my problem is going to say 7, and the answer from that was 2. Well, my overall answer is 49. So if this number right here matches a log with the same base in the exponent, they also cancel out, and you just get the number right here. You can just scratch them out. Okay? So for this next problem, I'm saying 3, and I'm raising 3 to the exponent that takes me from 3 to 11. Well, logically, I'm just going to get 11 for my answer. These are going to cancel each other out. So there's a lot going on in this lesson. Logs aren't easy, as I've said a couple times already. So don't be like scared or like weirded out if this isn't making sense at first. We will practice it, but it'll become more kind of easy for you the more you see them. So we'll do more with logs in the next lesson, but yes, we'll definitely be practicing this in class.